So my name is Nelly Sattari. I am the engineering manager at the platform team in Atlassian, working closely with Artem, as we discussed. So if you're ready, I'll go to the next slide, but you will get the QR code again. So in Atlassian, probably you're familiar with some of the products we have, like Jira, Confluence, Trello, Bitbucket, Opsgenie, and many more. We run all these products using thousands of microservices operating behind the scene. And as part of this talk, we are not going to encourage you to use microservice or not, but we are going to share what we do with these, like too many microservices, how we manage them, and we share some pros and cons that we actually observed, and we show you some solutions that we use. So, as I mentioned, just acknowledging there is no right and wrong, a definite right and wrong on which one is better. It's open debate, and depends on the situation, the size of the company, and the business that you are doing. Obviously, you have different choices. The life is full of choices, and it's all about trade-off, similar to what we have for microservices and monoliths. So it depends on what challenges you want to take. You actually choose different paths. All right, before we start, and we can test if you are joining the slides properly, could you please tell us, maybe in your last project, or maybe more often, what approach have you used most? Microservices, monolith, distributed monolith, and if you're not sure what does that mean, it's actually basically kind of a hybrid model where you break down your services into a smaller splitted pieces, but still you have some shared resources like databases, for example. So you still have that coupling going on. All right. So, yeah, I expected the same sort of result.
That's an interesting distribution.
Yes.
we have roughly the same distributed monolith and microservices.
Yeah, interesting. Okay. Cool. Thanks for sharing. Let's go and talk about just recapping some high-level problems that we observed with monoliths, and then we go through the journey. Artem?
Yeah, and to start with...
Is that working?
No, it's an amazing piece of technology.
Can you try? Perfect.
All right, so we're asking for your feedback again. So what do you think are the main challenges of the monolith applications?
Maybe just reflect back on your experience and share some challenges you observed.
All right, we get responses now. Many teams on one code base, deployment, multiple devs, high coupling, multiple teams, deploying, coordination of releases, same language. Right, so this touched most of the points we are going to discuss. And I will start with the main one, which is mostly highly discussed when you talk about the monolith. So people complain the most about the dev cycle of the monolith, right? Because you have a single code base, it's usually also an old code base with old frameworks. And if you want to experiment, there's very little room for experiment. You cannot bring the new shiny framework because you have to maintain the old one. So now you need to migrate the old one to new ones, and you can use the new one. So it blows up the scope, and it forces you to suboptimal solution. If you, even not about speaking as a framework, but even speaking of language, if you've been in an industry long enough, you probably remember the Java update was a big deal, 10 years ago. Major update was worth of few months of work. Right, so it's insane. And that kind of working also pushes us towards more waterfall, right? Because you have a long development cycle, you accumulate the changes, And it's done. Now you push it out to the testers, deal with it, and then testers test all of this. And when it's time to go to production, you also, again, throw it over the fence to SRE teams. Why SRE teams? Well, because the code base is so big that not a single developer can say what is happening, right? So you hire a dedicated team to just maintain their runtime. It's their job. And it creates a lot of internal conflicts. Because as a SRE team, I want to have monitorings, I want to have metrics, I want to have good and consistent logs, I want to have alerting, dashboards, whatever. And it started to conflict with the main features, how I, as a member of a SRE team, can advocate to adding this to my application, right?
Cool. All right. Another problem with monoliths is the single point of failure. Just to make sure we are all aligned on the definition, obviously it's referring to the critical part of the service. When it fails, it might cause a significant outage for the system, and it might bring an entire system down. So monolith is very famous for causing these sort of issues and lack of reliability on the code base. The second factor that we want to talk about is the security on the same aspect. So let's look into some details. So with the reliability, obviously, monolith systems are tightly coupled. All the modules are in one code. When part of the module is impacted, the entire system there is a likelihood that the entire system is going to be down. So the operation will be significantly disrupted. On the other hand, microservices, you have separation of concerns. So when part of the system or service is down, they're less likely that the whole application is going down. And you basically distributed the failure points. We call it isolated failure points. And this way we have obviously enhanced reliability in that regard. Same for the security. So when attackers can get into the system and compromise part of the module, it's much easier for them to get into the rest of application. And because the whole application is a single unit. But what happens is the increased blast radius for the whole application. And there's a higher vulnerability chance for your system. So these are some known issues of monoliths in regards to reliability.
However, microservices are also not a silver bullet, right? They may address most of the points we just discussed with the monolith. However, what people usually not realize is that they are bringing their own issues. And let's try to recap for those of you who are working with microservices. What are the main challenges you're facing in your day-to-day job with developing microservices?
Yep.
Mine is naming.
One database. Increased complexity, latency.
All right. So we have service discovery, coordination, infra dependencies, database, complexity, cost, diagnosis, authorization, complexity again, coupling, deployment pipeline, latency, complexity. That's interesting topic on complexity because microservices are not bringing you complexity. They just how should I say it? Manifest this complexity you have hidden in a monolith. It's just become visible for you. You can literally see which parts of the system depends on each other. It's been hidden, now it's visible. So they are not adding extra complexity. But let's touch some of the points. So some of you mentioned development cycle trade-off. And the two main points here are lack lack of consistency and the local environment. What do I mean by the lack of consistency? So at the point when you decided you go microservices and each team is empowered to use whatever language they want, right? The next day you will have 100 microservices written in different languages. This is a Stack Overflow last year State of Development survey. You can see a few funny ones still here, like Groovy, Scala, Perl. And there's always a developer in your team who would be advocating for the new thing, right? It's a very vocal guy who would, oh, it's so cool, let's write a new service. And what happens next is that you have all these multiple teams written in services written in multiple languages. And it not only stops on the languages, because once you choose your language, there's multiple frameworks to work on, right? Multiple build tools. And it's just keep going. You can go deep in here. And suddenly you start losing your agency because you cannot move developers between the teams. So if one team is constrained, you can no longer move people between. And similar thing is happening with external hiring, because previously you have a group of interviewers sharing similar tech stack, so you can you can interview candidates and then you can put them in any team you want, right? Now instead you have a team-specific tech stack, and it's become much harder to hire right people. And at some point, it might become very critical for the business. All right, the next point, really pain point, is a local development. So with monolith, local development is usually a solved problem because you have a single tool to build and spun up your application. With microservices, you now have 5, 10, 20 dependencies. And how would you develop locally? Right, there are two schools of doing this. One is saying, well, we will spin up the whole world. Right, we will spin up every single microservice. We have 7 days to do so. Let's do it. But that's bringing us back to the previous problem. If each team has its own tech stack and its own build tools, how would you standardize in a way that you are able to spin up the whole world? Right? On the other hand, we have a rise of new testing techniques. There's a great article from Martin Fowler, it's called Practical Testing Pyramid. It's talking about adding the new layers to like well-known testing pyramid when you have unit test, integration test, end-to-end test. One of them is contract testing, which is specifically for microservices and network communication between two services. Usually, companies and teams land somewhere in between. They might span up part of the world, just a continent, right? And the rest will test via contract testing. But that's the two main things. Okay. Can you go next? No?
I can move it. Cool.
Okay.
So, obviously what we discussed as microservices can eliminate the single point of failure for us at some extent. But you all mentioned complexity in the answers, right? And I completely feel you, and I would kind of manifest that complexity as distributed runtime trade-off. Which means now we have new sets of problems. We eliminate the single point of failure, but now we have new things to deal with. Let's look at a few of them. To start with, are we actually call microservices reliable by nature? What if you actually have just one instance in production for each module, each service. What if they fail? Look, there's again, higher possibility that the entire application doesn't really work when the critical functionalities are down. What I mean here is microservices by nature obviously are not reliable. What we need to consider for making these microservices safe and reliable. There are so many things. And the problem is now we have so many owners for these services, and everyone should have the same understanding about reliability, while previously we only had maybe 1 or 2 teams. So, as we discussed, monolith kind of help with the reliability, with the dependency and complexity between modules, but it has the reliability problem, and microservices on the other hand. What is the dependency chain here that I want to talk about? So when you have microservices, if you didn't consider proper design, you actually ended up having a lot of different sort of dependency. It might be circular dependency between services. It might be linear dependency, that your service wouldn't work without other services running in the production. Or you might be even, dependent on critical cloud services that if that's going down, you are in trouble. This is the graph that we generated in Atlassian about 2 years ago. This is insane, and it's just part of microservices in Atlassian, not the whole. So we realized that services has a lot of dependency, circular dependency, and it's actually quite dangerous, maybe more than a monolith. We call this a cascading effect, which means like a domino effect. When a service fails, there might be a lot of services fails afterwards, which we are going to discuss later again. So same as security. Previously, there was one security team and security champions working with the monolith team. They understand the logic, they understand the service, and quite aligned with each other. Now that you have thousands of services and hundreds of teams, it's actually a big hassle for the security team to make sure everyone consider what they need, the security requirements. And the fact that how can we enforce these security requirements, it's a big challenge. Not sure if you have incident management in your company as a big activity, but in Atlassian, it's a massive activity. I was just awake last week till 7 a.m. in the morning doing incident management, and this is routine for Atlassian. It's crazy. So previously, when you have monolith service, there is one team, everyone knows about it. When the incident happened, you just go and page that team, done. Now with having a lot of different services, who should I call? I'm the incident management, and in the incident, the most critical thing is time to address, time to recovery. It takes insane amount of time to actually find who is the service owner, who should I call. So you actually need foundations, you actually need tools for that. Otherwise, you will be in serious trouble. So, we talked about incidents, right? I want to ask you a question. What do you think is the most common problem in causing the incidents for the teams? If you want to pick the question, can you see the question on the slide on your phone?
Yeah.
Beautiful. So, okay, I'll start the question. Tell me among these options, which one do you think is the most common reason for incidents? And we will talk about it later. Okay, 1 second. Done. Perfect. Beautiful. 25 people got the right answer. I would probably reveal 3 first people. Who is Rabbit? You can look at your phone, it shows the name. Who is Rabbit? Can you see that? Yeah, there we go. Can we have 1 slide for him?
Yeah, please. Yeah, we forgot for mention. We have some swag for you to give out. So for the best answer, for the best questions and fast answers, we'll give out some swag.
And
so
who is
come over to us.
barefoot? Barefoot, please. And Ambriel? Okay, perfect. We have
Thank
3
you.
only. So cool. So as you all know about it, and you talked about it, having the frequent changes in production, maybe it's the most common reason for incidents. And that's the whole point of having microservices, like having more frequent release. And that's actually considered as DORA metric as well, right? How frequently you consider releasing your code to production. So that can cause a problem. Do we need to have a safe rollout? How do we do it? How people can consider safe rollout? That's another question.
All right, and that brings us to some operational trade-offs. We've been discussing previously that in monolith architecture, we usually have SRE team to operate the runtime. As we move to microservices and developers owning the whole cycle from the development to operation, because it makes sense. The scope is small enough, so each developer can understand what is happening, and that eliminates this internal conflict we have previously. Because if I, as a developer, going to be paged in the middle of the night, I want to be my feature well covered by logs, monitorings, alerts, and everything possible. I will probably also write a shit ton of tests prior to shipping anything to production, right? And then it raises a question, how could I make this logging and metrics consistent between the teams? Because again, as we discussed before, as a company, we don't want to lose this agency of being able to move people between the teams or hire people from outside. So I wanted something consistent between these services. And then again, a fail detection. As Nelly mentioned before, when the system is failing or application in general is degrading or failing, how would I detect which exact microservice is responsible for this failure? So these are operational trade-offs of running microservices. All right, so we just discussed that both monolith and microservices has their own pros and cons. And we want to discuss now as how we at Atlassian being able to offset these microservices trade-offs with our internal platform. We will give some specific examples. It will be probably more technical than previous talks, but don't worry, there's nothing too complex in here. So let's start with the definition of what is a platform or PaaS. Internal developer platform. These are our internal product. It consists of tools, services, knowledge, and it enables software teams in Atlassian to deliver their software autonomously and faster. Or speaking simply, we don't want Atlassian developers to think about infrastructure and all of the complexity and trade-offs of running microservices. We want them to focus on product feature delivery. So how we do it? So we have a very simple contract with our service owners. This is a YAML file. This is a bare minimum you need to give us. And if you look closely, there's not much here, right? You give us a Docker image, and that's basically it. There's nothing else in here. And then in return, that's what you get when you deploy a service. You get a DNS entry, you get a load balancer, you get an auto-scaling group with auto-scaling rules. You have a logs pipeline, you have a metrics pipeline, you have a host metrics, you have a service metrics, you have access to database if you need to, for other resources like queues and object storage, and it's all configured in a very secure and effective way. How we get from this YAML file to this piece of infra? Another critical part of our platform is a command line interface. So that's a main interface that end users or service owners interact with. And also all the like a build and automated system are also using this interface. So what you can see here is a simple command. It's saying service show. And what it's doing, you give it a service name and it outputs some meta information we know about the service, like what's the service name, who is the owner, what are the team members, in which environment it deploys, and so on and so on. So behind the scene, like all the machinery is done by us. So they give us YAML file, they say, please deploy to this environment, and we provision all the infra and deliver this Docker container into this environment, and it's become highly available.
Cool. Let's get back to the reliability issue that we had. So platform obviously is not here to solve all your problems in terms of reliability. But what we can do are actually two actions. One is enforcing some rules by being an opinionated platform and enforcing some rules for you, which I'm going to show you some of them. And the second thing is guiding you, more of playing a role of enablers other than platform. So guiding, educating, and making sure that we have tools for you, customers, to have visibility. And by customers, I mean Atlassian internal developers, to have visibility on your service. Let's talk about some of them. So a platform is opinionated, as I mentioned. If you ask for an instance for your service, like a compute, we actually enforce you to have 2 instances running in production. So there is no choice that you can drop one of them. And we actually enforce the service to be deployed into multiple availability zones. Obviously, that's one of the practices. If one AZ is down, it's much more, higher availability, and we can basically run the disaster recovery test by having a few availability zones. Speaking of these availability zones and the cascading effect that we discussed, obviously we can't stop it from happening, but what we can do is giving you some tools to test your services. Have you heard of Chaos Monkey? That's the practice initially introduced by Netflix. Basically, it's an activity that we go and randomly kill some instances in production. It can be on a schedule, or it can be like invisible activity, just ad hoc activity. So we go and kill instances. We sometimes go and pretend that an AZ availability zone is down, and we just sit and observe what happened to your service. Can the service recover? Is the auto-scaling rule configured properly? You actually, when the different instances are killed, you can actually figure out what service I'm dependent on, which is not visible on the surface. So this is a test that it used to be a schedule, everyone were ready, and there was a day, everyone go through this test. Now we are moving through more seamless and invisible activity to make sure that people are ready for that. So this is one of the tools we give service owners. We discussed about incident, right? I told you how it's crazy as an incident manager to find the teams. So one of the tools that platform provide is called Compass. Compass is service discovery or service catalog, known as service catalog as well. So basically, every single service that you create has an entry point in Compass, which you can go and search for the service. It brings who is the owner of this service. You can see on the right, the owner team. who is actually on a schedule and, like on call. Like if the incident happened, who should be paged? So you can see the name of the person and the team. So you can actually go and page them. You can see all about the service, like the metrics, the dashboard, the security scorecard, anything that the service has DORA metrics. So you can actually see the reliability and safety and health of the service as you go. So this is one of the tools we provide. We discussed about safe rollout as well, right? We have to do deployment, we have to roll out. How we can make sure that we have safety around rollout. So another tool that platform provide to engineers is Spinnaker. It's an open tool, open source tool, but we actually customize it quite a lot. So we enforce using this Spinnaker as part of the platform. And we provided two different approaches, blue-green deployment for services which is less risky. So basically you create a new environment, new stack, deploy, and then once you have safety, you have some smoke test, then you redirected the traffic. For more risky and tier 0, categorized as tier 0 services, you can use the progressive rollout, that you can gradually shift the traffic to portion of your customers. So you start with 10% of your customers, they get the new release, and then once you have, like we call it soaking strategy, when you have it, it's soaked in the production for a couple of minutes or days, then you start rolling out to the rest of the world. So people actually are enforced to use this tool. Let's go through the security.
All right, yeah. So security is probably most important in today's world because risk is usually unacceptable. So from the security point of view, we are doing a few of things as a platform. So it starts with default configuration, central management. Then I will touch briefly on service-to-service communication, which also been mentioned as one of the challenges for microservices. And then I will talk about the security scorecard. So default configuration, we provide them on multiple levels. So generally, service owners, they don't have any access to like host level configuration, say, like which users are actually created on OS, which OS is running, which privileges they are running with, they don't have direct access to a network. They can only operate like within the Docker container and use a network configured for Docker. Then network itself on a host also has firewall rules. So by default, it's all in private subnets. Only load balancer can talk to the specific instance, and even the load balancer itself in a private subnets. So it's only reachable from the edge. We'll touch on it a little bit later. And then we have different AWS resources provisioned in our accounts, such as databases, queues, streaming services like Kinesis. They also configured in a way that only this service and this developer can access this specific resource. It's very scoped, and service owners, they just don't have access to this configuration. So they operated in this restricted and very scoped permission. Speaking of central management, of course, service owners also don't have access to things like DNS entries or SSL and TLS certificates. It's all centrally managed. I already mentioned the global edge. So if you are not familiar with edge computing, it's basically an idea of having part of your compute closer to end user. An entry point, CDN is a great example of this when you deliver the static content, but it also could work for dynamic content. So, and on the edge, you can configure web application firewall, different cookie policies, TLS termination again, and so on and so on. And of course, we provide regular OS and software updates to all the services running on the platform. So when you talk about the service-to-service communication, it's basically two parts, right? We have authentication and we have authorization. In both cases, we have a standard which is adopted across all Atlassian. The first for authentication is ASAP, which stands for Atlassian Service Authentication Protocol. It's an open standard. It's based on well-known JWT standard, and it's basically when you have two services which needs to talk to each other, service A and service B. Service A signs the request or issues a token with a private key, and then it sends it during the request to service B. Service B, using a trusted entity or key repository to validate that request is valid, and if it's valid, you are authenticated. And then you need authorization. Oh, okay. And because we don't want to implement this flow for every single microservice at Atlassian, our solution is we have a sidecar. Sidecar is a Docker container which is running alongside your main service Docker container. So what service A is doing is just sending request. This request is automatically routed to this sidecar, service proxy sidecar. And then all the heavy lifting is done by the service proxy sidecar, both as a receiver and a sender. So as a receiver, it issues the request with a private key, and it's forward this to a receiver. On the receiver end, you also have the same service proxy sidecar, which receives the request. It validates against the key repository, and if it's valid, it passes it down to the service, and then service responds. So all this heavy lifting is happening inside the sidecar, and what really service owner just needs to do is to tell us which services they want to talk to. That's all. All right, and now to authorization, right?
Can you click?
Can you click?
Yeah.
Yeah. So for authorization, we using another open protocol. Internally, it's called POCO, which stands for policy control, but it's basically pretty much based on OPA, or Open Policy Agent. It's an open source tooling. It's a general purpose policy engine, and as you can see, it gives you a very simple way to define the access policies. In this example, we have a YAML file which is saying on this path in my application, this particular staff members can access when environment type is production, they can invoke this endpoint, or you can deny, or you can allow. Why it's important to have standard policy? Because as a security, I want to get insights on are there any too permissive policies? Are there any services which allows dangerous operations for untrusted entities, right? And when you have a custom authorization code in your application, it's very hard to do so. It's become like unmanageable. While when you have a standard policy on the other hand, you can just scan all of them and you can identify where you have issues. And the last part, Nelly already mentioned that we have a tool called Compass. She forgot to mention that Compass is actually Atlassian product that you can use. And it's one of my favorite products because it was initially developed as a part of our internal platform. And then we as a company realized that, oh, well, this is a problem our customers also having. It's a problem of discovery of the services when they operate in a microservices world. So part of this compass, you may have different scorecards. You can see there are a few here. It's a code-based readiness, another standard one, some beta scorecards. So you can define a security scorecard, for example, saying this service is using the POCO for the authorization, right? And it works great because all this information from the scorecards, it gets rolled out and it gets visible when you review the service health. And it happens on multiple levels. It starts with a team, like at Atlassian, we have a ritual called TechOps. It's a weekly review of all the services and their health, which is great practice on itself. And then it escalates up to org level and so on and so on. So you can have aggregated information from these scorecards on different levels. All right.
Can you click?
No. Okay, and now we roll into operations of the microservices. We already mentioned that we want some standard way for login for metrics for alerts. I will show you a few solutions we are using here, and we will start with logging. So as a platform, we provide the services standard login pipeline. I showed you at the very beginning how the minimal service looks like. There's nothing in here about logging, right? So our contract is very simple again here, is that we're asking you just output to standard output and standard error in a JSON format. And that's all we're asking for. The rest is taken care by the platform. And the rest is, we have a Docker login driver, which is reading from this output. It's sent it to a central place for processing and aggregation. Then it's sent to a central place for login viewing. We are currently using Splunk for this. And it's also taking care of moving this log to long storage for the cold storage. For example, after 30 days, you probably won't need much access to the log and so on and so on. It's all in very secure. And very similar way working the metrics. Again, in our service definition, we hadn't told anything about the metrics. So for the metrics, on every host, we run a statsd sidecar. Statsd is another open protocol, which is well known. There are libraries for any language. So what we are asking from our service owners is just you output your metrics using statsd library on a local host, and we will take care of the rest. And the rest is, again, we have statsd sidecar on each host. We have a local agent on host, again, run by platform, which is using the same statsd protocol to collect host-level metrics, such as CPU, memory, network utilization, etc., etc. And each service is running in the same manner because it's all controlled by platform. We also have a CloudWatch aggregator, which ships metrics into the same location to a metrics pipeline. And it all lands in a single metric backend where it's available to end user. And you can configure metrics and alerts and dashboards using all this aggregated data. And you might have noticed already that a lot of solutions are based on Docker sidecars. Right? So I would say it's a new library in a microservice world, where previously in monolith, if you have a common functionality, you just write a library and everyone using library and your methods. In a distributed world, you now have a sidecar and everyone just using sidecar and all your interaction is via network. And then we are going to alerts. Platform will automatically configure some default alerts for a service. For example, I don't know, 500 errors on load balancer, or you're maxing out on CPU, on your cache cluster, and so on. And you as a service owner also have an ability to override these default alerts or define the custom alerts based on the metrics. If you look at the example here, And if you're familiar with AWS and CloudWatch, you might say, oh, wait, it looks exactly like CloudWatch, right? So yeah, it is. We call it leaky abstraction, and it's done on intention. Remember in the beginning I said we want to abstract developers from the infra. So at the point when you need to write the custom alerts and override your defaults, you probably have enough knowledge of what you're doing. So there's just no value to abstracting it anymore, and we give some raw access to underlying resources. And finally, yes, it's all plays nicely in a bigger picture. So we have a standard metric pipeline, we have a standard logging, we have a Compass is a way to link services to the team, we have alerting, and it all comes down together because you configure all these metrics, we now know who to page. So by the time when something is happening in your application, you're downgraded or you're down, it is very likely that the team responsible for this is already being paged by automatic systems because they own their metrics, their alerts, their logs, they configure their dashboards because they as a team, they are on call for their services, right? We already discussed it. And yeah, it's make operating multiple services much easier.
Cool. So the whole point of having this internal platform in Atlassian is improving the developer productivity, which can address some of the problems from the engineers. But the main question, which we don't have time to cover it, but it's a nice segue to your questions on the slides, is what trade-off platform team actually have? Like, what is the challenges of running a platform team? Is it just simply, having a platform team and works well? No, that's a lot of challenges with a platform team, and that's why maybe it's not the best decision for all the companies. But there was one question here, if I can see. Yep. So the question was how we actually adopt, teams, encourage teams to adopt our tools. And that's potentially the most difficult challenge that the platform has, because we don't have a product to sell to customers. So we can't really measure our success by how much revenue we generated, right? But what we can do is any feature that we want to ship, we actually talk to customers, to Atlassian developers, and see if that's adding value to them. So we have a lot of interactions, per se, with the customer, and we kind of treat our platform as a product, but it's not there yet, I would say, I would admit. But this is a big challenge that we need to make sure that our service is going to be adopted by customers. So we have kind of, like having a lot of channels with the customers to identify what is their problem, basically, and what can be addressed in this big list. Obviously, we have so many more problems, like we only can provide custom, like generic solutions. We cannot really have custom solutions per each team, but we get a lot of requests from different teams that I want this feature, I want that feature. So it's all about trade-off every single day that we have to do. Another question on the slide is, the Chaos Monkey, is it going to be run on production or a staging?
Great
have like...
question, yeah.
Say it again?
Great question.
Yes, it is, yeah. We should have covered it. So we run it actually like 1 week in staging, make sure that the services are familiar and service owners are, into the exercise, and then next week we actually run it in production. We do it every quarter. And as I mentioned, we kind of get away from that scheduled sort of activity. We are getting into more seamless. So we actually run it in production for that purpose.
And it's been incidents caused by this,
Very
for
good
sure.
point. So everybody actually in that day are ready on call to make sure that they can respond to the incident quickly. Artem, it's about Forge. Do you want to go through that?
Atlassian recently entered the application platform space with Forge. How are you enabling Forge app developers to apply learners with microservice architecture to their own apps? Ooh, right. So to start with, we are not working directly with Forge app developers.
Yep.
However, we do work closely with the Forge platform developers, right? And it's a big challenge actually, because they ask a lot from the platform, because they are a platform themselves. It is very interesting discussion. Yeah, I think we may continue after the talk.
Yeah, unfortunately, we don't have time to cover the rest of the questions, but there are some reference that we actually put together for you. You will have it on your phone. And yeah, like they're all talking about how the platform works, and we kind of, collected some useful references. Thank you very much for joining us.
Thank you.